1 plus x.
So we're going to work problem 34 together. It's in the very back. Okay, you need to do whatever's necessary. Listen, hey, don't talk. You need to do whatever is necessary to memorize it. When you see an equation, you have to be thinking, hey, that's how I find all the xy pairs of some curve. So we don't take the time in this class typically to figure out what that curve looks like, but it looks like something. You find out all the xy pairs of the curve using this equation. So when you read a problem and you see an equation, make sure you're remembering that. It says find out points on the curve whose x-coordinate is 1. This is a written question from the AP test. It's not multiple choice. You have to learn to stop frequently. So I'm going to stop right here because they've asked me to do something, and that means they will be giving me points for doing it. So even if I can't do the rest, I want to get those first points for sure. So the x-coordinate is 1. That means I'm supposed to use this formula to figure out all points. That means xy pairs. So I simply replace the x-coordinate with 1. I don't know the y-coordinate. Always use parentheses when replacing a symbol. Questions to that? This is going to happen frequently throughout the year, this idea of finding points on a curve. So make sure it feels good to you. Keep going. I have y squared minus y equals 6. Okay, when you see that, you should be thinking of the word quadratic, which means we want to organize this equation slightly differently. We want to go like this, and then we want to factor. Don't forget to have good notation. Make sure you're using the equal sign. Good question. So not calculus, just reviewing things you learned in a previous class. So next thing I would do, don't look at this and say, oh, I just take the opposite. Look at this and say, what's the value of y which will make this equation true? So those values are y equal -2 and y equal 3. So I found out that this curve has points at the curve has points of 1, -2, and also 1, 3. Question. So key things to have memorized. Like I would have a list in your notebook of like, hey, in class, as we were discussing this, I kept hearing that I needed to have something memorized. I would make a little list in your book of like, I've got to make sure I have memorized that when I see an equation, I can use that equation to find xy pairs. I would also have a note that when I see a quadratic, I'm almost always going to have to factor. Okay? That's going to happen all the time. And you won't know when it's going to happen, it just happens. So, okay, questions? Cool. We've now earned probably 1 point on this written section of the AP test. So now we keep reading. It says, and write an equation for the tangent line at each of these points. Okay, when you read that phrase, write an equation. Make sure you're careful here. Sometimes they'll say slope. Sometimes they'll say equation. They're related but different concepts. Don't get them mixed up. In this case, we are going to write an equation, not just find the slope. So, on your little note page that says, hey, things I need to have memorized, I would add the following. Copy this over. On your little note page, I would write, every time I see the words equation of the line tangent, I'm going to have, so it's kind of like making a flashcard here. Every time I see those words in a problem, I'm going to have to remember this equation. Y equals like that. That also is not a new equation. You learned it in previous years. Make sure I'm not going too fast for you to make notes. Okay. This is the slope of the line. X1, Y1 is a point on the line. So this isn't, you're not writing this as you solve the problem. This is what you have to have previously memorized in order to solve the problem. So that's why I'm having you put this in your notes. Questions? Well, I would also add this picture. We are talking about some curve, like that. The curve is described by the equation they gave us. So you would label the curve as xy squared minus x cubed y equals 6. Then we have a line, or we have a point. Like one of the points we found was right here. A point on the curve at 1 comma, we'll do 1 comma 3, so we don't have to worry about the negative for a minute. 1 comma 3. So here's my point, 1 comma 3. And there's a line going through that point that is tangent, like that. This equation here describes that line. So you must have this information in your notes and you must get it memorized. So, question? I'm just going to watch you with pencils, make sure I'm not going faster than you can take notes. So. Whoa. So, in order to write this equation of a tangent line, I need a point that is on the line, but I have the points I need. I also need the slope of the line at that point. So I need to find the slope of the curve right here. Because the slope of the curve right there and the slope of the line are the same thing. So we learned how to do that in Unit 2. If I have an equation here that can be used to find every point on this curve, I can use my derivative rules to transform this equation into a new equation for dy dx. And the dy dx equation will be how I find all the slopes on the curve. So I'm going to summarize that again. Make sure you get it in your notes and you get it memorized. This is a very heavily tested topic on the AP test. So it will be heavily tested on test 3. Reminder, test 3 is cumulative for the entire semester. So this unit is learning a few new things, but also combining all the old things. So, let's see. Here's what I've got to make sure I have memorized. When they talk about an equation for a line tangent, I'm going to immediately think of this picture. It's the whole reason why that picture is on the wall up here. I'm going to remember that this formula is what I use to find every point on the curve. So this formula is how I find every point on the curve. I'm going to create a new formula, dy dx, using my rules, derivative shortcuts. This formula is how I find the slope at every point on this curve. So it's how I find all these slopes. That's this formula. And then the last formula over here, this is the equation for any line. So because they asked for an equation of a line tangent, I use this formula to find the equation of this line. Right here. This one. Questions about anything? Please, Paul.
The equation of the tangent line, is that universal for all questions?
The way you want to think of it, 2 points for Paul, is this equation is what you'll use anytime they ask you to write the equation of any line. So in this problem, they're saying write an equation for a tangent line. I've seen other problems where they'll say write the equation of a secant line. I've seen others where they'll say write the equation of a normal line. Haven't typically seen, well, no, I've seen others where they say write the equation of a line that's parallel. Anytime, parallel, that made no sense. Parallel. Anytime they say write the equation of a line, you're going to go to this. A lot of people want to think of this one, which isn't wrong, it's just harder for our class. Like, that's not wrong, that's the equation of a line as well, but it won't work as easily as this point slope form will. So, is that your question? Yeah. Pretty else? Please, Austin.
What do you use the dy dx for again?
2 points. So I'm just going to say them all again. So I use this equation if I need to find points on the curve. Points on the curve. I use this equation if I need to find slopes on the curve. I use this equation to write the equation of a line that happens to be tangent or normal to the curve. So 3 different equations, don't get them mixed up. Questions? Awesome. Okay, so now what I need is I'm supposed to be writing the equation of a line that is tangent to the curve at this point. So I have the point x1, y1. This is 1, this is 3. I need the slope of the curve at that point. So I need this formula. So now we're doing unit 2 things. Let's make another copy. Got it. So take the equation of the curve, x, y squared, minus x cubed y. This is an actual AP written test question. It's from the year 2000. So I apply the derivative rules. So I'm going to apply the derivative operator to both sides. Trying to save a little bit of work. First thing I notice is I'm going to have to use the add-subtract rule, and then I'll have to use the product rule. So I'm going to end up with y squared dx over dx plus x dy squared over dx. Be very careful when you subtract. You've got to have a big parenthesis. So I'm going to have y dx cubed over dx plus x cubed dy dx. I had to apply the derivative operator to this side to maintain equality. That's d6 over dx. So that's unit 2. If you need me to show, like I skipped a step here, I didn't like write it down. But if you need to see that step, you just wave at me like this and I'll draw it off to the side. So what I would have written here would have been this. I would have taken and said, okay, I've got to go d over dx of all of this. And therefore I have to go d over dx of the right half of the equation. Are you good to there? Just give me a thumbs up if that makes sense. Okay. Then I would have used the add subtract rule. So this would have become dx squared, over dx, minus dx cubed y over dx. This would become 0. Okay, letting me talk. And then I go to the product rule, so now we go right back to here. So these two blue lines, certainly write them in if it helps you. I'm just trying to get you to move a little bit quicker because now we're not just doing Unit 2 problems, we're using the Unit 2 concepts to solve a bigger problem. So, other questions? Awesome. Keep going. So now I have dx is 1. So I have y squared plus x. Okay, here I have to use the power rule. So I bring down the 2, and I have the y. The new exponent is 2 subtract 1, which is just 1. I don't write 1. Then I would have d over dx of y. That's using the power rule right here. If you need me to show more detail on how I got from here to here, you can just wave at me. When we find to show more, I just want to show what you need. So, okay, cool. Then we have minus. Don't forget the parenthesis. Y, using the power rule here, should be getting pretty fast at this. That's going to be just 3x squared. dx plus x cubed. An abbreviation for dy dx is y prime. And then this, of course, is 0. So we want to talk about any of that. And remember, yeah, please, Jake.
So you have y prime in the parentheses, but you have dy over dx. Why did you put y prime there?
3 points for Jake. No special reason. I was just kind of working it out. And then at this moment, I would notice what you would notice. I go, oh, wait a minute. These are the same symbol, so we probably should just call that y prime. Yeah, for sure. 3 points. Make sure your phone is put away. As I said, all through term 1, a surefire way to get a rude awakening and get a bad score on test 3 and then come to me and say, hey, can I retake test 3? And I'm like, no, because you wasted time in class on your phone. So you can't have the distraction. Calculus requires a high level of attention, and every time you shut off your brain to look at something else, you lose a lot more than you realize. So, questions? Cool. So, continuing with the Unit 2 stuff, now I'm going to have, let's see, y squared plus 2xy y prime minus, I have to distribute the negative, so this will become 3x squared y minus x cubed y prime. Questions? Did you catch up? And remember, you don't have to have a question in this class. You just start talking when things don't feel right. So. Cool. Rearranging, I'm going to move this to the other side of the equation, subtract that across. I'll add this across. So I'll be left with, let's make a copy again. Get some room. Oops, that's not what I wanted. This problem's a lot of work. Don't get too nervous. The other 31 problems do not take this many steps. So rearranging, I'm going to get 2x, y prime, subtract x cubed y prime equals 3x squared y, subtract y squared. Question, please.
So why did you move those two specific terms over and keep the other terms on that side?
3 points. So going back to our original intent, our goal is to come up with an equation of a line tangent. So I need to find the slope of that tangent line, which means I need to find the slope of the curve right here. The slope of the curve is found by finding this equation. Does that make sense? So that's why over here, I'm getting the dy dx terms on the same side. Because my next step is to factor dy dx. And then divide, and I'll have my equation that I need for finding the slope at any point on the curve. So that's why I rearranged the equation. Is that
Yeah, that makes
okay?
sense.
Questions? 2 more for Allison. She talked about this earlier. This is the equation I can use to find the slope at any point on the curve. I already know a point on the curve is 1, 3. I now can use this equation over here to find the slope at any point on that curve. I need the slope at 1, 3. So I use this equation to go find the slope at 1, 3. So the correct notation is y prime at 1, 3 will equal, and now it's just a matter of plugging in. Make sure you use parentheses in place of all the x and y's. Question. Chance to write that down. The AP test is usually the first test students have encountered in their, honestly, academic lifetimes, where they force you to pull together concepts from a lot of different places. It's not a real good simulation of a real life job, but it's closer. So, like again, just summarizing, to solve this problem, we had to remember that we had an equation here that we can use to go find points on the curve. So we did that first. That's where these two values came from. Points on the curve. In doing that, though, we had to remember to to use a quadratic and how to factor right here. Here's the factoring. Once we had the points, we had to remember this image and remember that idea of three different equations. An equation for finding the points on the curve, an equation for finding the slopes on the curve, and an equation for a line that is somehow associated with the curve, because there's lots of different ways the line can be associated with the curve. To do that, we had to go use our derivative rules to find our equation for dy dx. That's right here. Once we have that, we plug it in. Just raise your hand and tell me if you have a number here. Please show me your hands if you were able to find that number. Hands up. Who has it? Only two of you? That's exciting. Three, there we go. Let's go, Matt, what'd you get?
I got 0.
0? Raise your hand if you got 0. Let's check it just to be sure. For sure the top is 0. Bottom is not 0. Yeah, it's definitely 0. So show me your hands again if you got 0. 2 points, 3 for Matt. That means that at this point, the curve actually has a slope of 0, so my picture is wrong. The curve is doing something like this. The slope at that point is 0. That would be 1, 3. Slope is 0 here. Which means the equation of that line would be y equals 0 times x minus the x coordinate, which is 1, plus the y coordinate, which is 3, which means the equation of that line is simply y equal 3. On the AP test, if you get that far, you'll get another point. This FRQ is likely worth 3 points, would be pretty typical. The first point would be awarded for getting the points themselves right here. That would be 1 point on this FRQ. The second point would come from finding this. It's a good example of why the AP test doesn't really give partial credit. So you can do all that work and they will give you nothing for it unless you get the right result. That's why I really start out the first year doing multiple choice tests, because you have to get used to the idea that I've got to get it right. I'm not going to get credit for just showing work. Like I've talked to a lot of teachers in classes before calculus, they literally say, oh, work, 2 points. Like they don't even investigate as to whether the work makes any sense or not. They just give you credit for trying. They won't do that in a college class. So, questions, please.
Now don't you have to go back and solve for like the -2 part
Yes.
of the equation?
So we found the equation of a line. So what Carl said was, we found the equation of the line. It's a lot of words. We found the equation of the line tangent to the curve at the point 1, 3. I now must find the equation of the line tangent to the curve at the point 1, -2. So, similar process. I have my equation here that can be used to find the slope at any point. So I'm going to use that equation. Let's make another copy. Copying's a little slow here. There it went. So, erase all this. Points for Carl. So I just do it again. I go find y prime. Now at the point 1, -2. That's going to equal 3, parentheses 1 squared times -2. Always use parentheses to replace the x and the y. Question? So show me your hand if you have a result here. Who has a result? So Lexi? What'd you get? 2. 3 points for Lexi. Show me your hands if you got the same thing. 2 points, cool. So that means we have a curve. Curve has a point at 1, -2. There's a line tangent to that curve. Look at that shot. The equation of this line will be y equal the slope of the curve at that point, x minus the x coordinate at that point, which is 1, plus the y coordinate. And you don't need to do anything else to that, just stop. On the written section, you get full credit. Questions? Okay, the homework tonight is not 31 problems like this. Homework tonight is a mix because the goal here is to get you ready for test 3, which is like an AP test. It's going to have a lot of different problems. So a lot of the problems you'll see in the homework tonight are simply reviewing things you've already done. This was something new. That's why we did this together. So, any concerns, questions, anything here? Please, Jonathan. David.
This is test 2, right?
So, basically, here's where we're at. It's because of the whole hybrid thing, it's kind of confusing. We've finished Unit 2. All that's left to do on Unit 2 is take the test.
Oh, it's not the whole thing. So this isn't the same.
Say again.
So this isn't the same derivative. This is like after the test.
Let me say it back to you, see if I can say this better. The Unit 2 test is going to look just like the practice test you did for the practice test I sent you homework before fall break. So let me grab them here so it's not confusing anymore. So there's a green practice test and there's a purple practice test. That's what test 2 is going to look like. Just like, very, very similar to the practice test. The homework is now moving on through, but the homework does require that you know both Unit 1 and Unit 2. Oh, yeah. It's just adding up. Hey, quiet again. Just to make sure there's no confusion again, look, 3 points for David. Hey. So test 2, which you must have finished by October 28th, midnight. Test 2 is on Canvas. It's what you practiced prior to fall break. Okay, like just taking derivatives. And the green practice test and the purple practice test are good examples of the kind of thing you must be prepared to work out for test 2. Then as David said, Unit 3 now takes everything you learned from Unit 1 and Unit 2, combines those, plus starts adding additional things. So it's not a separate standalone unit. It's just putting everything together and continuing on. Please, Jonathan.
Do we need that paper of rules memorized for the term 2 test?
So the rule sheet, the pink rule sheet you had memorized for the test 2, yeah, you have to have that for test 3. So don't suddenly stop having it memorized.
When taking test 2, do we use that or do you want to?
No, the AP test does not allow any sort of aid, so I can't allow it either. So the instructions for test 2 specifically say, right here, get it to open. No calculator, no notes, no help. Yeah. So Questions? Okay, so back to here. To help you prepare for this first homework of Unit 3, I want to do one more thing with this example. So everybody look at me. Look at it. Come on. Don't miss this statement. I'm going to do one more thing on this problem that is not actually asked for in the problem. I'm only doing it to prepare you for a homework problem that's in the packet, okay? So it's not asked for here. I'm just doing it so that you can see, oh, okay, I get this other idea that I'm going to encounter in some homework problem. Let's get the copy to work. There we go. All right. In one of the homework problems, they're going to say, write the equation of a line normal. Make sure this is in your notes. They're going to say, write the equation of a line that is normal to the curve at a point. So it's almost exactly the same situation. We have a curve. We have found on that curve that there's a point at 1, -2. There's a line tangent to that curve. We could also draw what's known as a line normal to that curve. Normal means perpendicular. You learned that in a class previously. It's just been a while, so. Questions? So this problem does not ask for an equation of a line normal, but a homework problem does. It's not hard to create this line because we already have the equation for any line. It's what Paul asked about. 2 more for Paul. The equation of any line is always, y minus m x minus x1 plus y1. We simply need the slope of the line that is normal. Well, we found that the slope of the line tangent at 1, -2, that slope is simply 2. That means the slope of the line normal at the same point the slope of the line normal at that same point, 1, -2, that slope is going to be the negative reciprocal. So that will be 1/2 and then negated. That's the slope of the line normal. Question? Let you catch up in your notes. So to write the equation of that line, here we go. Y equals -1/2 x subtract the x coordinate, which is 1, plus the y coordinate, which is -2. If it's the written section of the test, you should stop right there. You'll get full credit for writing that equation of a line that's normal. We're going to talk about that. Okay, in the packet, the 31 problems in the buff packet, you have to be prepared to find multiple choice answers. So this is reviewing something previously, but the multiple choice answer could look like this. The multiple choice answer, make sure you put this in your notes. This is going to happen for sure. The multiple choice answer may look like that, but it may also be in a different form. So what I would do, if I'm doing a multiple choice question, is I get to here, and I go look at the answers to see if any of them match. If the answers are not in this form, the next most likely form will be this. distribute the slope. So go y equals, this distributes, so that'd be negative 1/2 x. Negative times negative is positive, so that's plus 1/2. Then subtract 2. They would then combine these two. Positive 1/2, negative 2, that's going to be negative 3/2. So it's possible that a multiple choice test may have the answer in that form. And you would have to be prepared to be able to find it. You don't need me to talk about that. None of this is calculus, by the way. This is just algebra. Last thing, they still may not have the answer in that form. So, sense the excitement. The last thing they might do is they might get rid of these fractions by multiplying both sides of the equation by 2. It's converting the equation to what's called standard form. So you're going to get 2 times y equals negative x minus 3. Then they'll rearrange so that the x is positive. So we'll end up with x plus 2y equals negative 3. That's another form that the answer might be in. So one of those forms, you have to go find it on the multiple choice. You need to talk about any of that. Please, Mike.
Can you back up and explain the third one?
Uh-huh. So you're asking from the blue to the green,
Yeah,
correct?
blue to green.
Awesome. So you don't have to have the names memorized, but if they help you, here are the names. This is known as point-slope form. This is known as slope-intercept form. From here to here, as you notice, that's pretty straightforward. From blue to green is converting to standard form. Standard form looks like this. AX plus BY equals C. So that's what I'm trying to get the equation to look like. They won't have these as fractions. So first thing I did is I multiplied both sides of the equation by 2. So when I multiply this by 2, I'm going to get 2y. When I multiply this half by 2, the 2 has to distribute. So 2 times negative 1/2 x will be negative x. 2 times negative 3/2 would be negative 3. So there. 3 points for Mike. Now I rearrange to make it look like this. So I move the x over here. Now I have x plus 2y equals 3. That didn't work. I don't know if that helped. Anybody else? Please, awesome.
Okay, so on question 34, I'm just confused how you got, like the very first step, how you got from the equation that's to find a point on every curve, and how you plugged in, or like to find the slope, the dx.
Oh, gotcha. So to find the equation for the slope at every point on the curve, what I did is I start with the equation of the curve itself, and I do what I did in Unit 2. I apply the ddx operator to the left half of the equation, and the ddx operator to the right half of the equation. Then I use the add-subtract rule to get to here. Derivative of a constant is 0. Then I'm back over here. This is the product rule. This is the product rule again to work out this and this. What's your question? Important. Yeah. Make sure you start a new tally. If you had a few tallies left over from term 1, that's fine. But don't forget to add up your points. You I hope everyone noticed that the extra credit at the end of the term becomes very important. So, cool. The bell will ring in just a minute here. So.